Lesson 12.2, Statistics and Parameters. Our essential question is, what are the 3 new statistical methods introduced in this section? Our first vocab word for today is statistical inference. You may recognize the word inference from language arts classes. The definition in statistics is very similar. So it's when you use the statistics of a sample to draw conclusions about an entire population. So an inference is when you draw conclusions. So we're going to use statistics from a sample, which is a small group, a part of a population, and we are going to use those to make conclusions about the entire population. A statistic describes a characteristic of a sample. So statistic goes with a sample. Then a parameter describes a characteristic of a population. So parameter goes with the population. I always remember them because the letters match. The letters match. So when it's a characteristic for the smaller sample, that's called a statistic. And when it's a characteristic for the entire population, that's a parameter. The next 3 vocab words, these are the 3 new statistical methods that we're going to work with. The first one is called the mean absolute deviation. To deviate means to be away from something. To deviate is like to be different. The mean is the average. The average when you add up all of the numbers and divide by how many there are. And then absolute is like absolute value, which is a distance. So if you put all of those words together, it's the average distance that each number is away from the mean. That's the mean absolute deviation. The variance is next. The variance is the square of the standard deviation. And the standard deviation is a really important statistic. It describes the spread of the data set. So when the standard deviation is a really small number, that means that your data set is really close, like the numbers are very close together. When the standard deviation is high, then the numbers are more spread out, which could indicate that there is an outlier in the set. Okay, we're going to focus first on our samples and populations. So remember that a sample is a part of the population, and it's not typically feasible to survey an entire population. So a sample is usually used. So after we identify the sample and population, we need to describe the sample statistic and the population parameter. So a meteorologist places 10 weather stations in a county to measure rainfall. So that means that my sample is going to be the 10 weather stations, because that's what he is using to collect his data. The population, though, is the entire county. So my sample statistic, the next sentence says the mean annual rainfall is calculated. So the sample statistic is the mean annual rainfall of the sample. So of 10 weather stations. Okay, and then the population parameter is the mean annual rainfall again, only for the entire county. So the sample statistic and population parameter are the same, except for one of them is measuring that characteristic of the sample, and the other one, the entire population. So mean annual rainfall of the county. Okay, the next one, a scientist randomly selects 20 trees in a forest. The mean height of the 20 trees is calculated. So the sample, 20 trees. The population would be all trees in the forest. Our sample statistic, the mean height of the 20 trees. And the same thing, but for the entire population. So population parameter, mean height, all trees. And if you want to put in a forest, you could add that, but I won't be that picky. Okay, our next one. At a local college, a random sample of 40 scholarship applicants is selected. The mean GPA is calculated. So, our sample, 40 scholarship applicants. Our population, all scholarship applicants. Our sample statistic, what are they looking at? They're looking at mean GPA. So mean GPA of 40 applicants. And then the population parameter, the mean GPA of all scholarship applicants. Okay, so hopefully you've got the hang of that, because now we're going to switch over to our new statistics. So how do you find the mean absolute deviation? Step one, we need to find the mean. So that means adding all of the numbers up and dividing by how many numbers there are in our set. Step two, we need to figure out the distance that each number in the set is away from the mean. So the distance away from the mean. And remember, distance is always positive because it's an absolute value. And distance, if you're measuring distance, you can't measure something and get a negative result. Distance is always positive. So whether it's bigger than the mean or smaller than the mean, doesn't matter. We're measuring how far away from the mean each number is. Then we're going to find the mean of those distances. And that's our mean absolute deviation. All right, so we've got our numbers. The first thing we're going to do is find the mean. So, I need to add all of these numbers. Of course, you can use a calculator. You really need one for sure on standard deviation. Divide by 1, 2, 3, 4, 5, 6, 7. It's usually a good idea to add your numbers twice, just in case. So I added mine, and I got 251. So if I divide that by 7, I get 35.85. So it's about 35.9. And it says to the nearest tenth for our final answer. So I'll just keep that 35.9. Now, each of the numbers, I need to figure out how far away they are from 35.9. So my first number is 12. So 12 happens to be 23.9 away. My next number is 22. So for each of these, you just need to subtract to find the distance. So 13.9, 47, 11.1, 51, 15.1, 33 is 2.9, 37 is 1.1, and 49 is 13.1. Okay, so then the third step is to divide that, add those up and divide that by 7. So, when I added that, I got 81.1. So if I divide by 7, my mean absolute deviation is about 11.6. Another mean absolute deviation problem. A rescue agency records the number of pets adopted each month over a 6-month period. 14, 18, 12, 17, 15, and 20. So step 1, let's find the mean. So 14, 18, 12, 17, 15, and 20. Add them up and divide by 6. So this one is 96. If I divide by 6, I get 16. So nice number. This one will be much easier to calculate than the last one. So now we need the distance. So distance away from the mean. So each of our numbers, so 14 is 2 away. 18 is also 2 away. 12 is 4 away. 17, 1 away. 15, 1 away, 20, 4 away. And then we'll divide that by 6. So 2 plus 2 plus 4 plus 1 plus 1 plus 4 equals 14 divided by 6. Our mean absolute deviation is approximately 2.3. So comparing this first mean absolute deviation to the second one, those numbers were much closer. The mean, or the average distance away from the mean, was only 2.3, so that would indicate that your numbers are a lot closer together than in the last set. Okay, how do you find the variance and the standard deviation? Very similar to the mean absolute deviation. There's just a little difference here. So we're going to find the mean, and then we're going to find the distance that each number in the set is away from the mean. Then we're not going to average them, not yet. First we're going to square each of them. Then we find the mean, and this is called the variance. So the only difference is we're squaring each of the numbers, the distances, before we add them together and average them. Then we take the square root of that, and that's called the standard deviation. And of all of these statistics, standard deviation is the one that statisticians use the most. So it's the most important. So it is more work than the mean absolute deviation, but the difference is very little. It's squaring each of the numbers before you average the distances, then taking the square root at the end. So just a little bit different. Okay, so our first set of numbers, we're going to find the mean. So add them. And this time we've got 5 numbers, so divide by 5. So 50 divided by 5 is 10. So we've got a nice number for our mean. Now let's find the distance away from the mean. So if our mean is 10, 5 is 5 away, 7 is 3 away, 8 is 2 away, 14 is 4 away from 10, and 16 is 6 away. Now, I'm not going to do that. Whew. I almost calculated just like the last one. Okay, so we've got our distance away. Now we need to square them. Square them. So very important difference when we're finding the variance. So 5 squared is 25. 3 squared is 9. 2 squared is 4. 14 squared is 16. And 6 squared is 36. Now we can average them. So I'm going to add those up and divide by 5. That gives me 90 divided by 5, which is 18. 18. And then I need to take the square root. So square root of 18 is approximately 4.2. So, to remind you which statistic is which, the variance was the mean of the squared distances, and the standard deviation was the square root of the variance. So, 18 is our variance, and 4.2 is our standard deviation. And we're done. One more example, just like that. So mean first, 92 plus 84, 71, 83, 195. And divide by 6 this time. $87.5. So next we have our distances. So 92 minus 87.5 is 4.5 away. 84 would be 3.5 away. 71 would be 16.5 away. 83, 4.5 away. 100, 12.5 away. And 95, 7.5 away. Now the tough one. We have to square each one of these. Square them. So this is going to take up some space for me. So 20.25 12.25 272.25 another 20.25 156.25 and 56.25. Okay, then I need to average them. So this is going to give me my variance. So I need to add these all up and divide by 6. So I've got 537.5 divided by 6. It's about 89.583 repeating. And then I need to do the square root. So this is my variance. So my standard deviation is about 9.5. So comparing this example to our previous one, These numbers are closer together with a standard deviation of 4.2. These numbers are more spread out with a standard deviation of 9.5. You should be able to write a summary now and check with your teacher for your homework assignment.